Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is the Oracle Cloud Database Quickstart. So in this session, we'll walk you through an overview of the different database services and tools available in Oracle Cloud and their key features. We'll also review database use cases and get an understanding of how to determine which service is right for you. I'd like to introduce Winnie Yang and Snell Jane, cloud engineers on the customer enablement team, as the main presenters. We have panelists who will be answering the questions. And with that, I will hand it over to Winnie to get us started.
Thank you, Olivia. Hi, everyone. Welcome to our Oracle Cloud Database Services Quick Start. So we'll just go ahead and get right into it. So on today's agenda, this is what we will be covering. We'll be covering different database services with different management levels, and also go over things like DataGuard, Golden Gate, and MySQL, some other tools that are very, very helpful when you're considering, an Oracle database. And then at the end, we do have a live demo for Autonomous Database. So just a quick kind of initial startup demo, but that will be at the end. So just another view at the Oracle Cloud ecosystem, kind of what piece we'll be talking about today, which is going to be Oracle databases, which is our focus today. So within Oracle Database Service, we do have a lot of different options for you to choose from. And so from left to right, that just means more manageability is on OCI. So starting from the left, we have our Oracle database on compute. So this is our standard database virtualized on the cloud. It does have default transparent data encryption or TDE. And here you can really take advantage of different virtual machine and bare metal options. Next, we have our Oracle Database Cloud Service. So this is our integrated cloud service, and it works with the Oracle REST API library. You can choose your rack, and you can also provision DataGuard manually, and it's also always encrypted by default. With Oracle Database Cloud Service, you can also have automated backup and patching. And that leaves us with the last two. So we have Oracle Exadata and Autonomous Database. So these will be our highly performant databases that are significantly more managed, but you will have Oracle Machine Learning in memory level, and the hardware will be optimized and managed for you, just to make sure that your resources are being spent properly, whether it's I/O versus read-write operations. There will also be options for rack, and you will have autonomous data guard, which is different from database on compute and database cloud service. This one is going to be single click, and what it'll do is create a compatible database, create the shape that you specify it as, and then create the connection between the two. So you're going to have, the entire set of APIs for management and also all the different metrics that go along with Exadata and Autonomous. And they will be converged databases. So they will have support for all the different types of database workloads, such as graph, spatial, JSON, GeoJSON, and etc. So our last database option here is Oracle Autonomous Database. So this one will have automatic scaling, tuning, and patching, as you can see here. So for scaling and tuning, these are going to be managed services. And the reason that it's important is that when you see a large list of features under a fully managed database, that's not saying, you can't have that on database cloud service. It's just that it's going to be out of the box in a fully managed database. So auto scaling is something that can be enabled also on database cloud service, but it just won't be managed for you like it will be on Autonomous Database, or ADB for short. So these are the options that we are going to talk about, and we are going to start off with Oracle Database Cloud Service. So this service has full-featured Oracle Database Cloud instances. You can either choose from Enterprise Edition or Standard Edition 2. It is encrypted for your protection, like we talked about earlier. We have a couple of different database versions. We have 11.2, 12C, 18C, 19C, and 21C. And here you can choose between virtual machine and bare metal shapes. You also have cloud automation under your control. So you can use either the UI, CLI, SDK, or API for provisioning, patching, backup, and disaster recovery. All right, so going into a more holistic overview. So for DBCS, these, as I said before, these are our full-feature Oracle Database Cloud instances. There are 4 different tiers of database license included options for this, or you can use bring your own license if you have a license on-prem. Bring your own license will give you a significantly reduced cost for a regular license, usually by 70 or 80%. So if you do have a license that you want to trade in towards the cloud, it's definitely not going to go to waste, and you can get more than your money's worth out of it. So for running and managing these databases, once again, these are converged databases, so you get enterprise class capabilities for any data and workload type. So you will either have single node instances or 2-node rack virtual machines. When it comes to cloud automation, you have the ability to automate provisioning, patching, backup, and disaster recovery using the API library. For the databases, there is actually no restriction on the databases based on what region you're based in. So basically, you can spin these up in all the regions around the world that OCI offers. Something else is that you have Enterprise Manager tuning and diagnostic packs included with Oracle Database Service. One of the goals for this specific database service is that it wants you to have as few databases as possible, ideally 1 database for all your data. And we'll see later that there are a lot of different connectors that are built in that will even connect to third-party databases. But the main idea is to not just have your data stuck anywhere. So then, because you'll have less places to look at, your admin is going to be greatly simplified, and a lot of the dashboards and visualization tools on OCI are going to be very broad and try to ingest metrics from different services so that you can have all your information located in one place. When it comes to enterprise database security, there is going to be secure by design databases so that everything will be encrypted by default. From the moment something is spun up, it will be encrypted, and until the moment you choose to take off the encryption. So some situations could be, if you had your own customer encryption or your own secret or key that you wanted to use instead of an Oracle managed key. And then there's going to be a ton of different built-in recommendations into the console and different tools so that it will just help you manage and secure your databases. So something like DataSafe is there to help you. And for built-in integrations, all databases on OCI will be integrated with the OCI REST API library, and many of them will have integration with other services as well. So moving on, we are going to talk about our next database option, which is ADB. So Oracle Autonomous Database is a combination of infrastructure automation, database automation, and data center operations that are going to be automated. Within Exadata and Autonomous, there is a lot of machine learning being built in, and a lot of this will go into disk controllers flash memory, and what it does. And so inside that, it'll go ahead and take a look at your operations. And a lot of the times it will actually run the operation in parallel to just see what memory system is going to run fastest for each operation. Next, it will store that information and then it will learn how to run your workloads more optimally. So at the core of our unified data tier is a converged database. So a converged database is a multi-model, multi-workload, and multi-tenant database. So you're able to query across multiple data types so that there are no silos. When we talk about multi-model, this means one engine with many APIs. So you can use the Oracle database as a document database, doing simple puts and gets with JSON, or you could use it as a relational database with intention for transaction processing. Multi-workload, this is going to mean one engine with many configurations. So maybe you have an IoT application and you need super fast writes, or maybe an analytical application and you need super fast analytical queries. Lastly, multi-tenant means containerization and orchestration for databases. So it's just a way of providing isolation, scaling out, and also transactional consistency across tenant databases, whether it's relational, document, graph, spatial, etc. It's going to be the best match for both cloud native and data center native applications. All right, so now we'll go through the different workload types that we offer in Oracle Autonomous Database. So at the bottom, we have Autonomous Data Warehouse, Autonomous Transaction Processing, Autonomous JSON Database, and Apex App Development Service. So we'll start on the left with Data Warehouse. So this will be columnar and it will be optimized for data warehouse, data marts, data science, or analytical applications. And then next we have transaction processing. So for transaction processing, this is going to be row optimized instead, and it's best used for transaction mixed workloads or data drive applications. Next, we have JSON database. So this is optimized for JSON documents and JSON-centric applications development. And lastly, we have Apex App Development Service. So this will be integrated with Application Express, and this is meant to help you develop and deploy low-code applications on a fully managed and secure environment. So all of these different types of Oracle Autonomous Database, they will come with Oracle Graph and Oracle Machine Learning as well. So before I continue to talk about how you can deploy Autonomous Database, Sunil, I want to ask you a question. What are the differences in features between Autonomous Database and Database Cloud Service?
So that's a good question because we talk about two different types of features, some of which are going to be, software oriented and some of which are going to be hardware oriented. So for things like machine learning at a memory level, those are features that are going to be exclusive to Autonomous Database. On the other hand, if we looked at something maybe like auto scaling, the Autonomous Database is going to have auto scaling. It's going to have it on. It's going to crunch all of your data. It's going to look at your usage. It's going to put it into a model, and it's going to really accurately scale up and scale down. DBCS, on the other hand, has the capabilities to do auto scaling. It's just not managed. So you'll have to collect the data yourself, maybe use a tuning pack, run the models. And once you've run the model, you can kind of get a good idea of maybe when you should scale up, scale down, and then you'll have to rerun your models to account for seasonality. So the idea is kind of that, you could take all the steps, labor, and talent to do something like auto scaling really efficiently on your own, or with Autonomous Database, you can simplify that. So depending on what sort of people you have on your team and what sort of workloads you're working with, you can do them on both. It's going to be a managed service on the autonomous database.
Awesome. Thank you, Sunil. So that brings us to, how you can spin up your autonomous database and what options you're looking at. So for deployment choices, you can either have it on shared or dedicated infrastructure on OCI public cloud. So with dedicated infrastructure, you are going to be the only person on the box. And with shared infrastructure, multiple people are on that box within the data center. But it'll still be separate because no one is going to be in your literal database. But it's just the overall box that is in the data center is shared. So for shared, this will actually be the simplest experience for your non-technical users. Oracle will automate and manage everything like deployment, lifecycle, software updates, and etc. You are just going in and choosing database resources like compute and storage and the region. Shared infrastructure is also completely elastic. So there is a low minimum size, which is 1 OCPU and 1 terabyte of storage. There are no fixed size building blocks, so you can scale up and down on demand with 0 downtime. And you can also be confident that it will automatically scale online for true pay-per-use. And then with dedicated infrastructure deployment, it provides your own database cloud running on dedicated Exadata infrastructure. So it runs all your databases, any size, scale, or criticality. It also will provide you with the highest isolation because it runs inside secure isolation zone for highest protection from any other tenants. And you can configure multiple Exadatas or container databases for intra-company isolation and also customize operational policies. So you have control of also provisioning, updates, availability, and density for your database. All right, so our next database service we are going to talk about is Exadata Database Service on Dedicated Infrastructure. I know it's quite a mouthful, but we'll take a look at the different choices that we have. Excuse me. So there are a few different deployment options that you can choose from. So starting from the left-hand side, you have on-premise. So in that case, we send you the box. You put it in your data center. It's yours. And then in the middle, we have Cloud at Customer. And lastly, we have public cloud. So Cloud at Customer is our hybrid cloud approach. So you'll still have Exadata in your data center, but you will be using a cloud subscription and it is Oracle managed. And then public cloud, this is formerly known as ExaCS, Exadata Cloud Service, but it's now been renamed to Exadata Database Service on Dedicated Infrastructure. So this will be in Oracle data centers managed by Oracle, and you'll be using a cloud subscription. So we can go ahead and talk about it. So we'll focus on not all of the features, some of the more important ones when it comes to Exadata. So a lot of the stuff is going to be similar to autonomous, but there are some things that are missing, and that will just be around the SQL performance tuning. But a lot of the memories in-memory things will be very similar. So things like Active Data Guard, you have that, which is the data guard that I mentioned earlier that can be provisioned in clicks. You can also have real application testing, advanced analytics for spatial and graph, and you also have a lot of different management packs just for that Oracle database that are all included for you. You have database partitioning. so that you can have isolation between your database users. And you also have some advanced compression algorithms. You also have the smart flash cache, which is the disk versus flash memory. And of course, you have that same machine learning that will be looking at your operations and running them in parallel on both types of memory to learn, which one is going to be faster so that it will give you increased optimized performance that is going to scale out with time as a database learns. Lastly, you have just a lot of dashboards and an extremely well fleshed out API library to help you manage all sorts of metrics based on your performance from your database. So an overview of the service, Oracle owns and manages Exadata infrastructure, and then customers can configure and manage OS and the databases. So you also have support for Exadata hardware and software, and you can run different Oracle database versions such as 19C, 18C, and some other ones as well. When it comes to deployment options, you can choose to provision Exadata in any of the OCI regions that are available. And then after choosing a region, you will go ahead and provision your software-defined network or virtual cloud network, we call an OCI. And then you can configure Exadata and then deploy your databases. So also similar to Database Cloud Service, you can use the UI, CLI, or APIs to automate provisioning, patching, scaling, disaster recovery, and backups. Now we'll talk about the different management interfaces for Exadata. So one of them being Oracle Cloud UI, which is accessed via an internet browser. But as I mentioned earlier, you can also access via REST APIs, SDKs, CLI, and even Terraform. All right, so now we'll kind of talk about how database backup options work when it comes to Exadata. So for your backup options, you are able to configure automated backups and then be able to restore your database from the last good state with the least amount of data loss or from a backup from a previous timestamp. So you have two different configuration options for automated backups. It's either going to use cloud storage and Exadata storage or just cloud storage only. So for the cloud and Exadata storage, this enables two separate backup sets, and it will contain periodic full backups as well as daily incremental backups. The backup to the Exadata storage uses space in the Rico disk group, and it does have a 7-day cycle between full backups and a 7-day retention period. For the cloud storage only option, this will use an Oracle Storage Cloud container to store periodic full backups and daily incremental backups as well, with a 7-day cycle between full backups, and you have an overall retention period of 30 days instead. So, Sunil, I want to ask you another question. Outside of configuring your database backup in the UI, what else do you need to ensure a successful database backup?
It's a good question. So Oracle is very consistent in the way on OCI it goes through its networking, its connectivity. So just because something is an automatic backup doesn't really mean it gets any special privileges. It acts just as any other backup would. So what that means is it needs a path out of your virtual cloud network. And so automated backups are going to be going to object storage. So what that would mean is you'll need a route specifying that you want the backup to go to object storage, which in this case is going to be done for you. But you'll also need a gateway outside of the VCN to make sure that traffic can leave your virtual cloud network and actually get to object storage.
Yep. Thank you for adding that onto, what a database backup would look like, to just ensure that, you do get your database backup, without running into any problems. So now we'll talk about disaster recovery with Active Data Guard, for Exadata. So you can either use the console to do this or APIs to enable data guard for an Exadata database and compute node database. So some things to note are that the standby database is going to be a physical standby. The versions of the peer databases, aka the primary and standby, they need to be identical with the same versions. You are limited to one standby database for each primary database, and the standby database is deployed as an open read-only database. So in this screenshot on our slide, you can see that it's taken directly from the console with intention to enable data guard. So at the top, the protection mode will be on maximum performance, and transport type will also be asynchronous. Then you'll go ahead and go in and configure your peer database system by selecting things like the region, availability domain, shape, and peer database system. Then you'll need to go through steps of configuring your standby database, and then you would be able to enable your data guard. All right, so lastly, from my section, we'll talk about Exadata database service on Cloud@Customer. So if you remember, this is our hybrid cloud option. So this is really for our customers that, sometimes they just can't move to public cloud for various reasons. It could be regulation requirements to be all local, or performance or latency requirements for different applications, database integration that could be tightly coupled with on-premises applications, or just risk concerns in general about sharing database systems in the cloud on Exadata. So with those concerns in mind, Exadata database service on Cloud@Customer was created to be a solution for these customer concerns. All right, so this is going to be my last slide on Cloud@Customer before I pass it to Sunil. So we'll specifically look at autonomous Cloud@Customer. This is put on top of Exadata database service on Cloud@Customer. It is the autonomous database on Gen 2, Exadata database service on Cloud@Customer. It looks the same as autonomous database running in the cloud. You have the same simplicity, agility, performance, and elasticity that you experience on ADB. You also get all the REST APIs, machine learning, dashboards, all the same things are going to be there. You can easily migrate existing on-prem databases to this. Existing applications in data centers can reconnect and run on this database, and the data is never leaving your data center. So this is just really a great option for any of those concerns that we talked about in the last slide. All right, so I will pass it to Sunil now, who will take us through some database-specific tools that you can see in our database options.
So first thing we'll do is talk about DataGuard. DataGuard is a disaster recovery tool, and it has a couple different versions. We talked about autonomous DataGuard earlier, and we're going to look at just Oracle DataGuard right now. So Oracle DataGuard is going to follow a active-passive configuration, which means the standby is only going to be used for failovers. And a failover, not to be confused with a switchover, is where you will take a current primary database, you will either manually or automatically fail over to a secondary site, which is now going to become the primary database and is going to be dissociated from the original primary database. If you would like to go back to the primary database, then what you can do is you can set up another data guard connection and go from the new secondary site, which after a failover has become the primary. You can initiate another failover and you can go back to your initial data site. Oracle Data Guard is going to use relog-based replication and is going to allow for very minimal, so zero or near zero data loss, and is going to fail over in extremely small amount of time. So your RPO is going to be, at most minutes if you're doing a manual failover. Some other use cases for DataGuard could be simple migrations and upgrades. So let's say you want to patch a database, but the patch is going to take a couple hours. You would prefer to just patch a secondary database, create that DataGuard connection, manually fail over, takes, a couple minutes. You're at your new database. It's got the upgrade already done. So that's how you could take the Oracle Data Guard and use it to help out with migrations. On the next slide, we've got Active Data Guard. Active Data Guard is going to be active, which means you'll be able to read on both copies of the database. And this is going to have automatic block repair, application continuity, and is going to follow switchovers. So last slide, we talked about failovers. When you fail over, there's no connection between the two databases afterwards. With switchovers, on the other hand, you can kind of switch back and forth as you will because the connection is going to be maintained. So, Winnie, I have a question. Given that you've got an active environment with Active Data Guard, what are some of the advantages you can take with that?
So Active has rolling database upgrades. So with that, you'll be able to update and patch your secondary database system.
Okay, yeah. So with rolling database upgrades, for instance, let's say we have something using like Java virtual machines, or something that we know is going to have a lot of downtime. What we can do is we'll have the primary data center and we'll have the secondary site. The first thing we'll do is we'll patch the secondary site. It'll incur that technological burden. The patch will be finished, switch over, we'll patch this one, then we'll switch back, and the end users will be none the wiser that both the primary and secondary databases were actually both patched while experiencing no technological burden. And similarly to DataGuard, there's going to be no data loss, and it's going to fail over or switch over in this case in minutes at most. So next, we'll look at Oracle Golden Gate. Oracle Golden Gate is going to be a data replication technology. And so previously, when we looked at DataGuard, this was going to be a redo log based transfer. And the way it worked was, depending on what stage your redo log was in, whether they've went through the buffer, whatever, you'll get your data replication. In this case, Golden Gate is going to work based off of trail files, and it's going to be able to take this log-based data capture system and take data from databases that are not exactly alike, right? So it's not going to be Oracle to Oracle. It's going to be, non-Oracle to Oracle, Oracle to non-Oracle, etc. You can have a whole ton of different ways to kind of take your data and replicate it across different databases. And this feeds into that whole one database for all data concept that Winnie talked about at the beginning of this presentation. So just for some examples, we see here that there's support for not just Oracle databases, but some open source stuff with MongoDB, some other databases with, Azure SQL, Teradata, and etc. And there's a lot more different data connectors that are supported. And if you want to know those, they'll be in the link because it was a little bit too big to fit on one slide. So here we have an example of some of the database replication patterns. We have unidirectional, bidirectional, peer-to-peer, broadcast, consolidation, and distribution. With Golden Gate follows a system called targets. So you'll have different targets at different paths in the database replication. And for each target, you can have up to, for each Golden Gate point, you can have up to 20 targets. So you can have very complex and intricate ways that you can push your data from one database to very many. So some of the most common Golden Gate use cases we have are going to be multi-cloud, which is where you're going to take data from one cloud and push it to the other. We're going to have on-premises to cloud. So if you've got data that you've got in your CPE that you want to push to a database in the cloud, Golden Gate is also going to be able to address that. For multi-region, let's say you have maybe data in one cloud, data in maybe multiple clouds across two regions, then you'll be able to take data and push it from one region to another. And then the last is going to be, if you're using SaaS applications, you'll be able to take your data from SaaS applications on, a number of cloud providers, not just OCI SaaS, and get them over to OCI. So here we have another slide with more use cases. And for Golden Gate is going to be, zero downtime. Your data is going to be up there. And when Golden Gate has to deal with maybe potentially databases going down, things of that nature, it's going to be prioritizing all the extract, the replicate options. So it's going to always be working towards getting data copied and making sure everything is in parallel with all of the places it needs to connect its data with. That's always going to be its first priority. So given that in mind, here are a handful more use cases. Some that we didn't talk about is, Stream Analytics is a data service. You can take your data from Golden Gate and push it to streaming. So you can get it to any data source you may need to. You see, we've got Kafka, Elastic as some examples on here. Another example is on-prem to on-prem. If you have two on-prem databases, you don't even need to be using, the cloud. You could be using OCI Golden Gate and create connections entirely on-prem. So the next piece we'll look at is MySQL. MySQL is supported on OCI. There's going to be two systems that we're going to take a look at. First is the standalone. This is going to be, exactly what it sounds like, single instance MySQL database. The second one is the high availability system. This is going to be 3-node MySQL database cluster, which is going to provide some automatic failover for zero data loss. That's going to have recovery time objective of minutes and recovery point objective, RPO, of 0. So we'll take a look right here at the architecture. So in this case, we see that the MySQL group replication is done across 3 availability domains. And for those who may not know, availability domains are physically distinct data centers, usually by 50 to 100 kilometers. So if there are 3 availability domains, when you set up the cluster, it'll populate the databases in all 3 different availability domains to give you the most resiliency. In some regions, there may be only 2 or 1 availability domain. If that is the case, there is another construct called fault domains. And fault domains are separations within a data center to give you additional resiliency. You can think of this as maybe different sections or different floors of a data center as a way to understand this. So if that's the case, then you will have these databases spread across multiple fault domains instead of multiple availability domains. And MySQL is going to use MySQL group replication to make sure that the data is replicated across all of these databases. So that way, in the event of a disaster, hopefully one of your other databases are going to still be up because they'll be in a separate data center, and you can use that database instead. So lastly, before we hop into our demonstration, we have the MySQL HeatWave, which MySQL HeatWave is going to be a service in MySQL that is going to do a handful of things. So first thing is that is going to be a query accelerator. So it's going to manage your queries for OLTP and OLAP applications all at once. So there's not going to be any need for ETL. You'll be able to query all your data in real time. And for applications, it's going to work basically without any changes. You're just going to be able to connect to the database and run as usual. And this is going to be a really powerful engine that can scale to thousands of cores. And this is going to be done using InnoDB on MySQL. So one final question for you, Winnie. How does MySQL HeatWave manage high availability to stay resilient?
So in MySQL HeatWave, there's actually a HeatWave node that will go ahead and inspect your different worker nodes. And what it does is it makes sure that they are running by the minute.
Right. So at all points in time, your HeatWave nodes are going to be inspecting all of the nodes, making sure everything's working. And in the event that it sees that one of the nodes is down, it's going to be replaced, reprovisioned, so that you'll keep that uptime in your MySQL HeatWave system. So here we are in the console, and we're going to be looking at the autonomous database. So here we see we have an always free autonomous database. And right here, compute storage is included, and we've got a data warehouse. So I'll click into our autonomous database. We see here we've got some general information. CID, license type, license included because it's always free, instance type, free, ability to upgrade to paid here. Resources, compute, and storage are going to be included. Let's see here. Is there anything else? Got network access type, TLS authentication, patch management level regular. We can see when the next maintenance is, etc. Data save, not currently registered. Encryption is going to be Oracle managed. So we see here that currently we cannot enable auto scaling. The reason is because we're on a always free instance. If you're in a paid instance, you'll be able to enable auto scaling either during provisioning or at any point in time after provisioning that you would want it. And auto scaling works for both storage and CPU. You'll also be able to do shrinkage options if you want to try and shrink your storage after you've been using it. So we can see here we can create a clone. We can manage our encryption keys. So if you want to use a customer managed key instead of an Oracle managed key and you want to rotate your keys, this is where you would do that. And for some of the metrics, we see here, get a handful of different metrics. You've got CPU utilization, storage utilization, sessions, execute count, etc. And using the API, you can do a lot more. There's a ton of other metrics that are able to be gathered. So the next thing you could take a look at is the performance hub. This is the demo database, so there's not going to be a whole lot going on in here. But if you do click it, you'll be able to see average active sessions. You'll be able to see different SQL IDs on things being ran. You'll be able to look at the performance of some of your SQL here. And lastly, what we'll do is we will take a look at some of the database actions. So these are all things that are going to be included with Autonomous Database. So I'm going to click View All. And let's say I want to use the web client for SQL. So here I am, going to be in, and I've got access to SQL Developer. Currently, I'm logged in as admin, which is not a role you'd usually use, but we could log out, log into a different user, and we can see I've got my tables loaded up here. It's just exactly what you would expect from SQL Developer. So you've got that in the web clients. You have Autonomous JSON, charts, data modeler, REST API library, Apex, and Graph Studio, which we talked about earlier. For administration, we have database users right here, where we would be able to click and you would be able to look at different permissions, look at your users, upgrade user permissions, and etc. For more of the monitoring services, you'd have Performance Hub and Database Dashboard. A lot of the resources for Database Dashboard, you saw, CPU usage, storage utilization, etc., are going to be in the console, but there's going to be a handful more metrics here. So right now we have no running statements, SQL statement response time, number of CPUs allocated, CPU utilization, storage allocated, storage used. So this would be the overview. And then you've got the monitoring tab as well, where we can see what's going on right now, which currently is nothing. So some of the last features we can take a look at are going to be Oracle Machine Learning. In Data Studio, though, there are a lot of different tools you can use. If you've worked with Data Loader, this is where you'll be able to load or access data from local files or some remote databases. For data transforms, this is a nifty tool where it's almost like a graphical interface, a GUI, for doing some of your ETL operations and transforms. It's very easy to use. And so I would recommend taking a look at it. And now we can go into Oracle Machine Learning. So Oracle Machine Learning is a tool that's going to let you run some models. If you've looked at any of the documentation around analytics on the Autonomous Database, you might have seen something called Oracle Machine Learning for Python or Oracle Machine Learning for SQL, or maybe OML for R, Oracle Machine Learning for R. This is how you're going to be able to do that. You essentially have languages like Python, SQL, and R in a wrapper so that you can run commands in all of those different languages on Oracle Machine Learning. And so we can see here you've got the ability to make different notebooks and some examples. So we can look at any of them. Let's look at this one. So this is where we're going to load data for use in other notebooks. And we can see here, we've got our cleanup script, which is a PL SQL procedure. We're loading data from GitHub. And we can see here, we've got some more SQL stuff, another PL SQL procedure. We're running our queries in place. And then we're going from SQL or from PL SQL to SQL, in where now we're going to be able to create these tables. And then in this same notebook we see here, now we're going to be using the iris dataset. This is a common database that is used as a sample for machine learning. And now we're taking this and we're creating this dataset from earlier, and we're running our code. And now, once again, in the same script, all in place, we're using Python, we're importing Oracle Machine Learning, so we can use OML. We're importing pandas and sklearn, so we can use data frame operations and do some machine learning in Python. So these are all going to be wrapped into these notebooks, which are really powerful tools for analytics. We got a question, where will we find this recorded session? I think Olivia's answering this, but on the Day One and Beyond page, which should be linked, there's going to be links to all of the different recordings from our sessions. So let me see if there's anything else. So the database connection, I guess, because we've got a couple minutes left, this is where you will find your wallet credentials for the autonomous database. And for backups, we see here we have the automatic backup retention period. It's going to be 60 days. And we can look at our backups here in the backups tab. And this is going to be where we'll see when all of our backups are happening, what the retention periods are. So if maybe there's a specific backup you need, you can grab it and make sure you save it properly. So that way, after the 60 days are up, you'll still be able to recover from it. Okay, then, that's all I had for the demo. If there's
But yeah, awesome session. Thank you, Winnie and Sunil. Really appreciate your time and help with the session. I hope it was a good learning experience for everyone. And thanks everyone for joining, and we hope to all see you next time.